Our next topic. The same complex algebra method. How will you apply it on a slider crank mechanism? Okay. So this is roughly a slider crank mechanism. We have a fixed link. We have AB crank, BC is connecting rod, and D this thing is the slider. Okay. So what we have to do, you can watch this only after watching listening the previous lecture, that is on 4-bar mechanism. Then only, okay, I am skipping all the basic things that first you have to listen that, then only you can listen this. Okay, so according to our method, the next step is we have to form a closed loop. So here, how will you form a closed loop? We have crank and connecting rod, and this is the fixed links. So if we join this fixed link to this fixed link, that means then it will become single link only, a single link only. So we have to join from A to C. Then you will get a closed loop. That is a point. Next thing. So this is our closed loop. Then we have to form an expression that is called a loop closure equation. For that, you have to consider each link as a vector. So here we are considering crank as a vector in this direction, connecting rod as another vector in this direction, and third we have fixed link as a vector in this direction. So slider is absent because slider is can consider only as a point here. So that is not what we are ignoring that in this diagram. You will understand then how we can include slider that in the next coming slides. Okay, so this is the closed loop, that's all. Okay, we have 3 links only here, and then what you can write is a loop closure equation, that is link 2 L2 vector plus L3 vector, these are in the same direction, is equal to L1 vector because in the opposite direction. So this is our first step. Now next step is we have to write in terms of exponential function a vector, that is vector A equal to its magnitude A into e raised to I theta. Similarly, you replace each vector term with that. So you will get this, that is L2 into e raised to I theta 2 plus L3 into e raised to I theta 3 plus L1 is equal to L1 into e raised to I theta 1, where L2 is the length of link 2 or crank, theta 2 is the inclination, L3 is the length of connecting rod, and theta 3 is its inclination, L1 is the length of fixed link, and theta 1 is its inclination. Okay. Next step, differentiate this expression. Okay, please, when I am not writing I don't all these things here, but you have to write in note. Next step, here you have to write loop closure equation, then write in terms of exponential function, then next you write differentiate with respect to t, then you can write this. Okay, this is the differentiation. So please watch carefully and listen carefully. How will you differentiate? There is a change from the 4-bar mechanism. So first, L2 e raised to I theta 2. Here L2 is the length of crank, it is a constant. So the differentiation of e raised to I theta 2 is enough. So L2 into e raised to I theta 2, differentiation of e raised to x is e raised to x only. So e raised to I theta 2 into, but theta 2 is a function of what time, so we have to differentiate that d theta 2 by dt, and I is a coefficient of theta 2, that is also included here. It should be included because I theta 2, so I into d theta 2 by dt, that is a differentiation. Okay. Then in the previous lecture I didn't include I because please note, if you have any doubt, please note the previous lecture, we have I in all terms, so I didn't mention that actually, because I was supposed to mention but I forgot, but I is available in all terms, so we can directly eliminate I from each term. So there is no I in the previous case, but here we cannot do so, that's why I'm writing I here. Okay. Then next term L3 into L3 is a constant, then e raised to I theta 3. Differentiation of e raised to I theta 3 is e raised to I theta 3 into differentiation of I theta 3, that is I into d theta 3 by dt is equal to L1 is equal to L1 e raised to I theta 1, differentiation of this. So here is the change from our 4 bar mechanism. Here, how will you if you do accordingly 4 bar mechanism, how will you do? You can say L1 is a constant, so L1 into differentiation of e raised to I theta 1. But you cannot say that if you think, because L1 is not a constant here. Okay, now see your diagram. L1 is not a constant. Here we are including slider. Okay, even though it is not visible here, but slider is there because the position of slider is here now at this instant. But when the crank rotates, the position of slider changes. So as the position of slider changes, this is the point where we are on slider only. As the position of slider changes, length of one will change. So one will fixed length will move to a large distance and then come back or shorter distance accordingly with the rotation of crank. So L1 is not a constant, that is the change. Therefore you have to differentiate L1 also, that is a change. Now you have to use a product tool for differentiation. First you will do keep L1 as constant and differentiate e raised to I theta 1. So L1 into differentiation of e raised to I theta 1 is e raised to I theta 1 into d theta 1 by dt into I, plus keep e raised to I theta 1 as a constant into differentiation of L1. What is differentiation of L1? dL1 by dt. So this is the change. Okay, this is a differentiated expression of the loop closure equation. Clear? Now in this, our objective is to form an expression that can be used to find the output velocity. What is the output velocity? Velocity of slider. In most cases it will be velocity of slider, in some cases it will be velocity of crank. Okay, so then now here this term d theta 1 by dt, we know that theta 1 is 0 because that is horizontal and there is no direction change for L1. The direction of L1 is same, therefore theta 1 is a constant. So d theta 1 by dt will be 0. So this term will be 0. So we have remaining only this term at the right hand side, that is e raised to I theta 1 into dL1 by dt. Now you see, what is dL1 by dt? So L1 is defined as the length from this point to this point on the slider. So as what will be the rate of change of that length? That length will change only when slider move. So the rate of change of L1 will be the velocity of slider itself. Okay, therefore dL1 by dt we can written as velocity of slider, or you can write it as V of S, velocity of slider. In the next slide. Okay, next slide. This is same. The below we have I into we rearrange we substituted d theta by dt as omega, that you already know. D theta by dt is omega, so this d theta 2 by dt will be omega 2. So I into L2 omega 2 e raised to I theta 2, I into L2 omega 2 e raised to I theta 2 plus I into L3 omega 3 e raised to I theta 3 equal to, this term is 0, we have remaining Vs into e raised to I theta 1. This is the second expression. Okay, then next you replace e term with the cos and sine components. So what we can write, I into L2 omega 2 into what is e raised to I theta 2? Cos theta 2 plus I sin theta 2. So put in bracket cos theta 2 plus I sin theta 2 plus I into L3 omega 3 into cos theta 3 plus I sin theta 3 is equal to Vs into cos theta 1 plus I sin theta 1. That is this equation. Can check whether you write correct properly. I L2 omega 2 into cos theta 2 plus I sin theta 2, I L3 omega 3 and minus this. Now what is the next step? After writing this, next step is to to separate the real and imaginary part of this expression. So what is the real part? Is usually the cos part and imaginary part is sin part. Now, but in this particular expression, see the for first two terms we have an I term. So when we say cos I is coming with cos theta 2, so what we can say is the cos term is L2 omega 2 cos theta 2 into I. So that is not your real part. It's a change from previous 4-bar mechanism. But we have again sin theta 2. There is already an I, so we will multiply this I with that, so we will get I square or minus 1. Then sin theta become 3 and sin theta term become the real term for this first term. Okay, also for second term we have an I here, so there will be a change in the real part. Then the third part we have cos theta standing as the real part and I sin theta standing as the imaginary part, because we have no I outside the bracket. If you have any doubt, check the previous one. Okay, we have no I here. We have I in here only, that is here, but that is 0. Therefore, that term is not there. So we have only remaining this term. Here we have no I. Then we can say, if you separate the real part and equate to 0, what we can say, so here we have, sorry, one more thing, here this is Vs is on the right hand side, so I take it the left hand side, so it will be, there will be minus sign and the right hand side becomes 0, so this is minus sign and right hand side is 0. So the real part will be what we have minus L2 omega 2 sin theta 2. That will be the real part. Here second part we have I minus L3 omega 3 into sin theta 3. Third part we have minus Vs cos theta 1 is the real part. So this write that minus L2 omega 2 sin theta 2 minus L3 omega 3 sin theta 3 minus Vs cos theta 1 equal to 0, and that is 1. Then you write the imaginary part, that is here imaginary part is L2 omega 2 cos theta 2 plus L3 omega 3 cos theta 3 minus, here the imaginary part is sin term, Vs sin theta 1. So that is second expression, that is equation 2. What is the next step? We have omega 2 in the first term, omega 3 in the second term and Vs in the third term. Omega 2 is your crank velocity and that is your input. Vs is your cider velocity, that is this is cider velocity and this is our output. Omega 2 is angular velocity, Vs is linear velocity. Okay, please note that also. Then omega 3 is connecting rod velocity, that is not required when we are finding output velocity. So we can eliminate this term. So to eliminate this term, omega 3 term, what you have to do, coefficient should become equal. So the coefficient of omega 3 in second equation is cos theta 3 and L3 cos theta 3, and coefficient of omega 3 in the first expression is L3 sin theta 3. So you multiply the first expression with the cos theta 3 and second expression with the sin theta 3. Then you can match the terms and get eliminated. Okay, you will get eliminated. Then this is 1 to cos theta 3 and 2 into sin theta 3. So that step is also here. You can refer minus L2 omega 2 sin theta 2 into cos theta 3. Again next term into cos theta 3. Last term also into cos theta 3 equal to 0. That is equation 3. Similarly 2 into sin theta 3. So sin theta is included in all three terms, sin theta 3, here also sin theta 3 and here also sin theta 3. That is equation 4. The next step, here we have minus L3 omega 3 sin theta 3 cos theta 3, and second expression we have plus L3 omega 3 and cos theta 3 sin theta 3. So if you add both expression, this term will be the middle term will get eliminated, or omega 3 term will get eliminated. So you add 3 plus 4. When you add 3 plus 4, this will be eliminated. The remaining will be minus L2 omega 2 sin theta 2 cos theta 3 plus L2 omega 2 cos theta 2 sin theta 3. That is here L2 omega 2 cos theta 2 sin theta 3 minus L2 omega 2 sin theta 2 cos theta 3. The remaining term is this one, minus of Vs cos theta 1 cos theta 3 plus again minus, so minus Vs sin theta 1 sin theta 3. That is minus Vs cos theta 1 cos theta 3 minus Vs sin theta 1 sin theta 3, and that is equal to 0. Okay. Then next you have to simplify this. So the first two terms is L2 omega 2 is common. So we can write L2 omega 2 into cos theta 2 sin theta 3 minus sin theta 2 cos theta 3. That is sin A cos B minus cos A sin B. So that is equal to sin A minus B. And what is A? Theta 3. What is B? Theta 2. So L2 omega 2 into sin theta 3 minus theta 2. Then the next two terms we have minus, we will take minus common. So we can say minus in bracket Vs cos theta 1 cos theta 3 plus Vs sin theta 1 sin theta 3. So take Vs outside. So minus Vs outside into what we have remaining is cos A cos B plus sin A sin B. So what is the simplification? Cos A cos B plus sin A sin B. It will be cos A minus B. So what we can write is cos theta 1 minus cos theta 1 minus theta 3. So we have already a minus Vs. So it will come like minus Vs into cos theta 1 minus theta 3 equal to 0. Or if you take it the other side, we can say this minus will be eliminated. We can say Vs cos theta 1 plus theta 3. So again simplified the same expression I noted here. L2 omega 2 sin theta 3 minus theta 2 minus Vs cos theta 1 plus theta 3. Okay. Then take the outside, take to right hand side and take Vs on the left hand side, remaining all terms to the other side. We can say Vs equal to L2 omega 2 do sin theta 3 minus theta 2 plus divide by cos theta 1 into cos theta 1 plus theta 3. This is your final expression for slider velocity. Okay, so this expression can be used to find slider velocity. Here L2 is the length of crank, that is known. Omega 2 is the input velocity, that is also supposed to be known. Then we have three angles, theta 1, theta 2 and theta 3. Now you see which one is theta 1, which one is theta 2 and which one is theta 3. So theta 1 is inclination of this link. Which link? Fixed link. So inclination of fixed link is theta 1. So what I can write is theta 1 equal to 0. Next we have theta 2. What is theta 2? 1 second. This is theta 1. Okay, hope you understood. Next is theta 2. So theta 2 is inclination of crank with the same axis. So this is theta 2. Okay. So how will you measure this? From the horizontal x-axis. So the direction of measuring is this. Now finally we have theta 3. Theta 3 is the inclination of connecting rod from the same axis. So axis is represented as this blue line. So you have to measure in the same direction. Okay, please note. So you have to measure like this. This will be your theta 3. Okay, that's all. So that's all about our connecting complex algebra method for slider crank mechanism. So in the next video I will mention I will just explain a problem on both 4-bar mechanism and slider crank mechanism using the same method. Okay, thank you.